All right, so we are starting just a real quick unit on trig. Excuse me. So it's labeled 11.1. In your book, this is actually 13.1. We are skipping the next two chapters. This is the last material we'll learn. We're going to do 3 days of trig. We're going to review the trig stuff on Thursday. You will have a test on Friday. And then we have 3 classes next week. We'll do some exam review, talk about note cards and such. And then you will take your final. All right?
Hypotenuse is the first answer.
Yes.
The first answer is hypotenuse. What's the second one?
All right, so first we have to talk about right triangles in general before we get into the trig stuff. So if you have the right angles right here, the side across from the right angle is what?
The hypotenuse.
The hypotenuse, good. And then you're going to be given a specific angle that you're talking about. Across from that angle, we call that side the opposite. And then the side right next to it, or the only remaining side, is called the adjacent side. So it depends what angle you're talking about. So for example, if I'm looking at that angle right there, this side, hypotenuse is always the same. But in this particular triangle, now across from that X, that's the opposite. And then this guy's the adjacent. But if you're looking at a different angle, for example, if I'm looking at this guy, now this side is the opposite.
What's that red with the dash there?
And this side is the adjacent side. Now, in trig, a lot of times you will see the angles labeled in Greek letters. This is the most common one. This is theta. It's just treat it like any other variable. If you want to change it to an x, that's fine. A lot of times the missing side is labeled as x, so I maybe would avoid x. But yes, that is the Greek letter theta. So right below it says, notice that the opposite and adjacent sides might be, that blank is different. It's not up on the board, but I'll show it to you anyway. So depending on the placement of the angle, the opposite and adjacent side could flip-flop. Hypotenuse is locked in. Those two could change. Questions on just general setup for right triangles? All right, so here are the actual trig functions. There are 3 of them. It's sine, cosine, tangent. You guys probably remember this from your geometry days. The memory trick is SOHCAHTOA, and that tells you basically the words in the order that they appear. So if you're talking about sine, I'm going to use theta again. Sine theta. That's opposite over hypotenuse. So that's where the S is sine, opposite hypotenuse. So. Hello. All right, the next one is so you have so and then ka, that's cosine, and that's adjacent over hypotenuse. We discussed that already. It's theta. It's a Greek letter. It's just theta. 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 So a lot of times in trig you'll see Greek letters used for the angles. So that's theta. And then toa is tangent. So tangent of theta, that's opposite. I'm going to abbreviate. I'm kind of out of space. Over adjacent. So what we're going to be working on today, you're going to have the angle measure. So you won't use theta, you'll use an actual degree angle measure. And then it's the ratio that's equal to, those are side lengths. One of them will be missing. And then we're going to do like a cross-multiplying sort of deal to find the missing length. Sound legit?
Nope. Go ahead.
All right, so the hardest part is deciding which trig function you want to use. So here is the angle that we're looking at, the 22-degree angle. So what information do I know?
You know the hypotenuse?
I know the hypotenuse, and what am I looking for?
The X.
That's the adjacent.
That's the opposite.
Opposite would be right over here.
No way.
I don't have the opposite side. So I'm looking for the adjacent side. I have the hypotenuse.
Cosine.
That is cosine. So I would do cosine
Cosine.
23
X.
degrees.
What?
You put the degree measure there.
Cosine.
And then adjacent is my x.
X.
Hypotenuse is the 13.
So how do you put that in the calc?
So we are going to multiply both sides by 13.
Yeah. So 13 cosine 23. Put
So
it in the
depending on the calculator, sometimes you have to hit 23 then cosine, like on the phone calculators if you turn it to the left,
What are we rounding to?
rounding to 1 decimal place.
Well, then it's 12.0.
So yeah, when you do cosine 23, or sometimes you have to hit 23 cosine. Like this calculator right here, you have to hit 23 then the cosine. On those, the TI-30s, I think it's the other way around. It's cosine then 23. Play around with your calculator. You should get 0.9205 and so on. And then you multiply that by the 13, and you end up with 11.96. We're going 1 decimal place, so you can round that up to 12. Try it on the calculator. If you don't have one, come grab one. This is all calculator work today.
So you did 12.
All right, so number 2, I'm looking at this angle right here. So this, the 4.2 is the what?
Opposite over it.
Opposite. I'm looking for the adjacent. So which one is that? Tangent. So tangent 17 equals opposite over adjacent. Now, these are the ones where I think about it as like cross multiplying sort of a deal. Because you would end up multiplying both sides by the x, right? So you'd have x tangent 17 equals 4.2. And then to get the x by itself, you'd have to divide by tangent 17. So in your calculator, you're going to do 4.2 divided by tangent 17.
ABC.
Or like on my, I was using my phone earlier just because it's the only thing I had handy.
What?
And so I did 4.2 divide by 17 tan equal, and it worked.
13.7.
13.7 is correct. So go ahead and play around with the calculator for a minute. Every calculator is different, so I can't really tell you how to type it in. If you're using the ones like on that poster, the TI-30, you have to close the parentheses on a lot of these where you're typing in a fraction. So just...
So
yes, that's the same one. Got it. So number 3, we have this angle right here. And I have the opposite and I have the hypotenuse. So which trig function do I want to use?
So sine.
Sine. Good. So sine 34 equals 8 over x. Good. All right, so again, you want to multiply by the x and then divide by the sine. So it's actually going to be like x equals 8 over sine 34.
They got scared.
All right, do you all agree? 14.3?
No.
No.
Oh, I see what I did wrong.
Double check.
Are you sure that's right?
I'm not sure. Someone took my answer key from right now. As we were just discussing, I have lost my answer key.
I'm sure that's right.
Oh, I did it wrong.
Yeah.
We got some time today. I mean, there's only 4 examples. What? Mine know. It'll turn up. All right, last one. So the 62-degree angle. This is the what?
Tangent.
Opposite. This is the adjacent. So you are correct. Tangent is going to be our go-to on this one. And then this one, you just multiply both sides by 5 to get the x by itself. So x is going to equal 5 times the tangent of 62.
And then you wind up getting 9.4.
Do you guys have any questions on trig? This is the basic trig ratios. How you feeling?
Worksheet.
Okay, so yes, your homework is all worksheets this week, which is a nice change of pace. There will not be a homework check. I still need to figure out a way to keep you accountable for the homework, so I'll think of something.
Because this is easy stuff.
Yeah, I might just check to see if you do like a completion grade sort of thing. I'll think about it. I will get back to you for sure. Okay, do you guys have any questions though before I hand out the worksheet?
No.
Quiz over this stuff on Friday, so keep up with it. It's happening quick.